All right, guys, so now we are going to look at the section 2.5, lecture 2.5, further applications of right triangle. You can use trig function and their definitions to compute angles and distance in real-world problems, and you should be able to solve real-world application by drawing right triangle to represent the situation and then solving the right triangles. All right, so first, bearing. In navigation, the word bearing means one of the two things. First, the angle measured clockwise from due to north. So if that's north, that is 110 degrees. We're having a bearing of 110 degrees right here. Second of all, an angle measured from either due north or due south in either a clockwise or counterclockwise direction. The direction is specified as the rotation either to the east or the west. So let's imagine that you have a north 31 degree east. Well, oh, why do I say the 5 when I want to write east? East. Well, that's north. East is on the right. This is 31 degree to the east. And actually, let me represent that in red. Okay, so right here, I got 31 degree to the east. Now, if I have a north 45 degree west, this is north and this is west, 45 degree is right there. We have 45 degree right here. Now, if I give you another one, let's try to look at south of 85 degree east. So, sorry for the noise. That is east. This is south. 85 degree. Actually, 85 degrees, it's close to 90, so it's going to be more something like this. 85 degrees south, 85 degrees east. If I look another one, let's say a south 15 degree west. West, this is south. 15 degree west, 15 degree south, 15 degree west. All right, so now let's try to practice by trying to work on this problem number 1. We have a radar station, A and B, was separated by 8.66 kilometers apart and on an east-west line. Station A detects an airplane at a point C on a bearing of 53 degrees. Station B detects the same airplane on a bearing of 323 degrees. Find the distance of the airplane to both stations. So first, it's very important for you to read properly your problem. And second, it's very important for you to represent your problem the best way. So here's the representation. All right, guys, so I just represent for you the problem. I'm going to repeat that. We have two stations, A and B, right here. Distance of 8 apart of 8.6 kilometers on an east-west line, east and west line. The station A detects an airplane at a point C on a bearing of 53 degrees. So we have the station A detecting on a bearing 53. Now I know what is the bearing. It's an angle measured clockwise from due north. So I know that my C is going to be here. and the station B detects the same airplane on a bearing of 323 degrees. So the bearing of 323 degrees is going to be right here. Okay, this is 323 degrees for the bearing, when right there the bearing is only 53 degrees. And all right. So it's going to be very easy for me to define this angle right there. What I notice in blue, I'm going to rewrite this angle in green. Why is it 53 degrees right here? It is 53 degrees because 323 minus 270 degrees, knowing that 270 degrees will be right there. Let me use another color. I'm going to use the color, let's see this one. That is 270 degrees. Oh, interesting color. And so I end up to have my angle equal to 53 degrees. Just to remind you that, so if I call 37 degrees the angle A, let me call this the angle A, and 53 degrees the angle B, I'd like to remind you that A and B are complementary. A and B are complementary angle. This is the reason why 37 degrees plus 53 degrees equal 90 degrees. So I got a 90 degree angle for C. So if I want to find B, which is the distance between the airplane and the station B, what do I have? I know that the hypotenuse is equal to 8.6 kilometer. The hypotenuse 8.6 kilometer. I know that the angle is 37 degrees, and I know that the cosinus of 37 equal B over 8.6. Therefore, B will be equal to 8.6 multiplied by cosinus 37. I may be very careful when I'm going to plot this value inside my calculator by making sure that I am in a degree mode. And I'm supposed to find the value of B equal to 6.9 kilometer. Now, if I want to find C, A, which is, I'd like to remind you, A is the distance, and actually B was the distance between, I made a tiny mistake, but it's the same idea. B is the distance between the station A. This is the distance between the station A and C. So now if I want to find the distance between the station B and C, which is basically finding the value of A, I know that the angle is 37 degrees. I know that the hypotenuse is 8.6 kilometer, and I know that the sinus of 37 degrees is equal to A over 8.6. Therefore, A is going to be equal to 8.6 multiplied by the sinus of 37, and you are going to find 5.2 kilometer. Okay, 5.2 kilometer. All right, guys, so now let's jump on the problem number 2. And this problem number 2, radio station A and B are 9.2 kilometers apart, and the station B is on a bearing of north 76 degrees east relative to station A. I will let you continue to read this problem. Let me first draw the picture and then I will be back at you. So guys, first of all, if I need to have the radio station A and B are 9.2 kilometers apart, so I know that C equal 9.2 kilometers apart, and station B is on a bearing of north 76 degrees east relative to station A, which means that this angle right here is 76 degrees. Then the station A detects an airplane at the point C on a bearing of south 55 degrees east. So south 55 degrees east is right here, 55 degrees, south 55 degrees east. I would like to remind you that we are basically dealing with the angle B. So first of all, 90 degree minus 76 degree is going to be equal to 14 degree. Equal to 14 degree. Where is this angle 14 degree? This angle 14 degree is going to be right here. All right. So this is where you are going to have the angle right here, 14 degree. Now, if I want to find the value of the angle B, well, I know that B is going to be equal, this angle B is right here, the angle B is right here, it's going to be equal to 90 minus the angle 14 degree minus the angle 76 degree. Minus 35 degree. And what is this 35 degree represent? This 35 degree represent the angle that you have right there. Okay? And therefore, the angle B is equal to 41 degree. So it's all about trying to define the value of the angle B. Okay? If I know that I have 55 degree right here and 76 degree right there, it's pretty easy for me to define the value of the angle in between, and the angle A right here is going to be equal to 49 degree because the angle A is equal to 180 minus 76 minus 55, which is 49 degree. At the end of the day, it's pretty easy to define the value of the angle C because it's going to be equal to 180 minus 41 degree minus 49 degree, and so the angle C is a right angle. All right, so now, if I want to find the side A, the cosinus of the angle 41 degree, the cosinus of the angle B is equal to A over 9.2. And so A is going to be equal to 9.2 times cosinus 41 degree. And you're supposed to find the value of A equal 6.9 kilometers. I will let you find the value of the side B by yourself using the fact that you are looking for the cosinus of the angle 49 degree, which is equal to B over 9.2. All right, guys, so I will continue the other example because this section is a little bit taking a bit more time. you will have a second video making about 15 minutes.